This lesson is all about problem solving using gas law. I'm just gonna go ahead and introduce two different laws today. As you can see on the left side of the column, I have Boyle's law, state that at the constant temperature, volume is inversely proportional to its pressure. Therefore, when we do the equations, pressure times volume is equal to constant, because when you increase pressure, volume decreases. Before you get to this point, you will be able to, or at least exposed to the information uploaded on the hub. So you will be reading this information and summarize the main idea of the gas law and the kinetic theory, because however gas behave, it is directly related to kinetic theory. And you will read the passage and summarize. And by doing that process, you will be able to realize at 3-3 Boyle's law relating pressure and its volume, you will be able to use the data to come up with the theory. Because however the law was or has been constructed is based on experimental data. And you will maybe later be able to do the lab for these lessons. With this one, as you can see that as the volume decreases, the pressure, what happened? The pressure increases. That is inversely direct, which is volume varies inversely proportional to with pressure. And also, when you look at the graph, you should be able to see this graph. The one on the left, which is A, which is this one. What happened? As the volume increases, the pressure decreases. That's what it is. And we will be able to do the lab to confirm this result later. For second experiment for Charles' law, when you read 3.4, Charles' law relating volume and temperature, pressure is constant. But the temperature must be in Kelvin. So if it is given in Celsius, you must add 273 to the initial Celsius temperature. And as you can see that, this is a graph relating between volume and temperature. It is directly proportional to. For example, as the volume increases, the temperature increases as well. And that's how we came with this formula. V1 divided by T1 is equal to V2, volume 2 divided by temperature 2, but the temperature must be in Kelvin. So basically what I just did was I was just giving you a guideline about how you would summarize the information from the reading material, because part of our skill in this class is for you to do some reading and to be more literate by reading it. But for the next part of the equation, we're trying to do the problem solving to confirm the law. Let's look at these two questions. For example, if I don't tell you which one relates to which law, would you be able to do so? That's a skill that by the end of these lessons, you should be able to distinguish between each law by reading the passage. So So question 1, if for example 22.5 liters of nitrogen gas, the keyword is the gas, at 0.984 atm atmospheric pressure are compressed to 0.5 or 0.954 atm at constant temperature. So basically this one is actually telling you that at constant temperature. So we look between these two laws, which one is constant, which one temperature is constant. And this one is at constant pressure. This is the key word. So this one, you go back to here. Which one is constant? Oh, right here. The temperature is constant. Therefore, we only have pressures and volume. So let's double check. We should have 4 different variables. This is what do we have for this one? The first step, identify. I'm just going to say step 1. Identify given information. So I'm just gonna say that's what I have for the first one. So I'm just gonna put volume 1 because the unit is in liter. So volume is in liter or milliliter. Okay. Keep reading. Oh, that's the pressure. That's the first one. So 0.984 atm. The reason why you know it is pressure because of the unit. Compress. So it says that this is the first pressure and it compresses down to this one. So this one therefore will be P2. Which means volume 2 we don't know. P2 is equal to 0. So we have, okay, the first step is to identify given informations. So second step is to write equation. Easy, simple. P1 times volume 1 is equal to P2 times volume 2. So P1 0.984. Remember, just because it is first, it doesn't mean it is the first one. Pressure times volume, that's what it is saying. Pressure 2 is 0.954. My volume 2, that's what we're looking for, but you don't know that for sure. So after you have substituted these informations, now you're gonna have to solve for it. So in order for us to solve this problem, right, we just going to have to multiply these two. I'm going to simplify them. Divide by 0.954 because I'm trying to solve for V2. So I'm get rid of that. So divide by 0.954. My second volume should be, let's look at calculators to see what we have. It's the same way. Sometimes you might be able to calculate the second volume instead of second. I'm sorry. Sometimes you might be asked to calculate for second pressure instead of volume, but you do the same way. So what you would do is you will plug in 0.94. That's our first pressure time. 22.5 enter, divide by 0. Okay, make mistake. 0.8984 times 22.5 divide by 0.9. The answer is 23.21. 23.21. Confirm with theory. You know, as pressure goes up, I'm sorry, this is the first one. Look at the graph. What does it say? This is pressure, this is volume. So our first volume was 0.984. Right here. That's P1, right? 0.984 was our volume. Okay, let's double check right here. So our volume is 22.5 right here, right? And the pressure is, I'm just gonna say this is 1, so but that's the first one is right here. But then, you know, when you have less pressure, right here, your volume should be increasing. And the answer is 23.21. So, this is the graph. It goes this way. So basically, it is correct because the pressure goes up or pressure goes down. Volume goes up. That's what it is based on the first law of this one. So let's look at question 2 real quick to see what we know. A container containing 5 liters of gas is collected at 10 Kelvin and it's allowed to expand. So first step, 5, that's volume 1. T1 is at 100 Kelvin. Volume 2 is at 10. T2 we don't know. So step 2, V1 divided by T1 is equal to V2 times T2. I'm just gonna go ahead and rearrange the information so that I will just solve for the new temperature. So I'm looking for T2. So I'm doing T2 is equal to V2 divided by V1 times T1. That's what it is. So now you replace this one. Your volume 2 times 100. My volume 1 is 5. So that makes it, I'm putting it right here. 10 times 100. Let's do it again. 10 times 100 divided by 5. Ten times 100 divided by 5. That should give me 200. 200 Kelvin. So step 3, let's look at the graph. Volume 5. My temperature 100. Volume 10. The answer is 200K. This is 200. See? It is directly proportional to volume goes up, temperature goes up as well. That's what it is. That's how you would confirm the result.